Hello, physics students. Mr. Steenerson here, and we're going to walk through the scenario of a car and its motion and plot both the position, time, and a velocity time graph to match that. So let's take a look at what we have. We have a light turning green, and then the car is going to get faster in the positive direction. Now, those clues break down like the following. We know it's positive, therefore the velocity is going to be in the positive quadrant, and it's getting faster, so there must be a curve on the position time graph. So I'm going to curve upwards like this, indicating that I'm getting faster while moving away, and my velocity is a constant slope, and it's in the positive quadrant. Awesome. Let's take a look at the next one. We have a car that's moving at a constant speed in the positive direction. Again, my velocity must be in the positive quadrant, so I know that's happening because of the positive direction. For my position graph, it's going to increase at a steady rate, so it's a positive slope, and my velocity is constant, so it must be looking like this. Then next scenario, we are getting slower in the positive direction. Again, I'm going to be in that positive quadrant for velocity, but this time my slope on my position graph will be changing to where I start off at a fast rate of speed, and then I get slower as I'm going through. So it must be something like this. I'm going to curve over where I have a steep tangent in the beginning, and then it curves over to a shallow one, but I'm getting farther away. What that looks like on a velocity graph is I start at a high speed, and I end up at a low speed, similar to that. And I know it's in the positive direction, so it's got to be in the positive quadrant. Now we're waiting on a U-turn, so this place right here, we are stopped. So that means my position time graph will be at the same position, and my velocity time graph will be 0. So that's a stopped scenario. When I have a flat line on the position graph, it's a 0 velocity. Gets going in the other direction, so we're getting faster in the negative direction now. All right, now here's where things switch, right? Every time we had a positive direction, positive, 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 we were in the positive quadrant on our velocity. When we are in the negative direction, we're going to switch, and our velocity graphs will now be in the negative side of our velocity time graph. So what we're going to take a look at then for the distance graph is it speeding up or slowing down? It's getting faster in that negative direction. So we've got to start with a not that much of a slope and end up with a steep slope in the end. And we're starting at a low velocity and increasing our velocity in the end of our time. So it looks somewhat like that. Constant in the negative direction, we're going to have a position time graph that looks like this. So we are going in the constant, and we're going to have a velocity time graph that is a straight line, just horizontal. And then we're getting slower in the negative direction. So instead of speeding up, we're slowing down. So in this case, our velocity is starting at a high velocity and ending at a low velocity. So I must have a steep slope in the beginning and end with a shallow slope. So think about when you're talking about slopes, think about the tangent to the curve, if it's speeding up or slowing down. That'll help you. We have a steep slope, so we're going really fast here, and then not so steep of a tangent and a pretty shallow tangent here. So we're going at a high velocity, a medium velocity, and a low velocity at the end of those journeys. Hopefully this helps clarify things with the graphs. Thanks, and have a great day.